Hello everybody, my name is James Munford and I'm a junior bioengineering student at Clemson University. Today we will be answering a few questions pertaining to mechanics to help you further understand mechanics and the effects it has on biological systems. So let's get started. The following question asks us, which of the following statements defines creep as it relates to material properties? And the answer choices are 1. Progressive deformation responds to constant force over an extended period of time. 2. A solid material's ability to deform under tensile stress. 3. The ability of a material's mechanical properties to vary according to the direction of a load. 4. The rupture of a material under repeated cyclic stresses at a point below the normal static breaking strength. And 5. The ability of a material to absorb energy and plastically deform without fracturing it. Now that you know the answering choices, I'd like you to take 20 seconds to try and answer this question on your own. Okay, this question is fairly straightforward. It just asks us to define a term. In order to answer this question accurately, you have to know what creep is, though. So, what exactly is creep? Well, creep is the tendency of a solid material to move slowly or deform permanently under influence of persistent mechanical stress. It can occur as a result of long-term exposure to high levels of stress that are still below the yield strength of the material. And this is just a strain versus time curve that illustrates the creep behavior. As you can see, there is a region on the graph past the yield stress that has a very small slope. This region represents creep. And that region is just stage 2. It shows the minimal creep rate. The slope of this is the minimum creep rate. And up here you have fracture. So let's go back to the question and see if you can answer this question correctly this time. I'll give you another 20 seconds. Oops. So what did you get? The correct answer is number 1. The reason that the answer is 1 is that it reads progressive deformation responds to constant force over an extended period of time, which is very similar to the definition that I gave you. So, correct answer is, number 1. Even though we have found the correct answer, let's look at answer choices 2 through 5 to see why they are incorrect. Each of these choices actually defines another term related to biomechanics, or just mechanics in general. Choice 2 reads, a solid's ability to deform under tensile stress. This definition defines the ductility of a material. So this is just ductility. Another answer choice reads, the ability of a material's mechanical properties to vary according to the direction of the load. This actually doesn't define a mechanical property so much as it defines a general rule for mechanics. The fourth answer choice reads, the rupture of a material under repeated cyclic stresses at a point below the normal static breaking strength. This defines the mechanical property of fatigue, not creep. So this is just fatigue. The fifth and final answer choice reads, the ability of a material to absorb energy and plastically deform without fracturing. This defines the toughness of a material, which again is not creep. And that is just toughness. I'll write it down here. And I'm sorry for the poor penmanship. It's kind of hard to write with the mouse. So, on the next slide, I've decided to sum everything up for you. So once again, creep is defined as the progressive deformation response to constant force over an extended period of time. A material's ductility is defined as a solid's ability to deform under tensile stress. Fatigue is defined as the rupture of a material under repeated cyclic stresses at a point below the normal static breaking strength. And finally, the toughness of a material is defined as the ability of a material to absorb energy and plastically deform without fracturing. And a general rule of mechanics is that the ability of a material's mechanical properties vary according to the direction of the load.